in the meantime, we move on to the different states of matter. Now, when I talk about different states of matter, we know the different states of matter are solids, liquid, and gas. Each state of matter has its own properties, and each property depends primarily on the interparticle spacing and the way they have been arranged in the structure of that substance. Now, the interparticle spacing depends primarily how these constituent particles have been arranged in different states of matter, primarily depend on the interparticle attraction. Now, what exactly is interparticle attraction? Again, as the name would suggest, interparticle attraction is the attraction experienced by different particles, the constituent matter of constituent particles of that matter. So, in case of liquid, for example, here, if I say कितना ज़्यादा attraction ये दो particles आपस में feel कर रहे हैं is simply the interparticle attraction of different states of matter. So in liquid I can say that जो liquid के particles होते हैं they experience a moderate force of attraction towards each other. That means they are not very strongly attracted towards each other, which results in an interparticle gap or loosely packaging of the particles of liquid. So the interparticle force of attraction simply means दो particle के बीच में कितनी force of attraction है. अगर force of attraction ज़्यादा है तो particles would be tightly packed. If the force of attraction is more, the interparticle distance would be less. That means अगर दो molecules, अगर दो particles के बीच में force of attraction ज़्यादा है, that means they would want to come close to each other, which would result in a lesser interparticle distance, which is in case of solids. The interparticle distance is less because the force of attraction between the particles is high. In case of liquids, the force of attraction between the particles is medium. That means it is neither too high nor too low, and therefore the interparticle distance is, again, compared to solids, a little far away, and therefore the force of attraction has weakened between the particles. This is the case in liquids. When I talk about gases, the force of attraction between the two particles or between the particles in general is very, very less, and therefore the interparticle distance increases, and therefore we say that the particles of gases are loosely packed, in fact very loosely packed, because there is no affinity and there is no liking towards each other due to the very, very low force of attraction. Right? In case of solids, the force of attraction increases, therefore the distance decreases between the particles. In case of liquids, the force of attraction reduces a bit, and therefore the interparticle distance increases a little bit. In the case of gases, the force of attraction is very, very less, and therefore the interparticle distance increases. So I'll be just representing it very in a very brief manner here by writing force of attraction as FOA. So force of attraction in this case reduces a little bit, therefore interparticle distance increases a little bit. In case of gases, the force of attraction reduces a lot, and therefore the interparticle distance increases a lot, which means the gas के molecules, the molecules of gases are very loosely packed. I hope the concept of interparticle force of attraction, the interparticle distance, and the particulate nature, that is the constituent particles, is clear to you by this time. Right? A very specific mention of this property has been mentioned further, that is the strength of these attractions depends on the nature of the substance and the interparticle distance. So the strength of these forces ultimately decide the physical state of the substance, right? And a very, very important part in this paragraph is even a slight increase in the distance decreases the interparticle force drastically. That means अगर हल्का सा भी increase होता है distance में, दो particles के अगर बीच में हल्का सा भी distance बढ़ जाती है, इसका मतलब ये है कि जो उनकी interparticle force of attraction है वो बहुत ज़्यादा decrease हुई है, which has propelled the atoms or the particles to move away from each other. अगर वो बहुत ज़्यादा पास होंगे, it would mean the force of attraction is pretty high and therefore the particles are very close to each other. But as even by a very slight margin the particles move away from each other, it means that the interparticle force of attraction has reduced drastically, right? Which happens in case of the conversion of state of matter, which we'll discuss further. Now, adding on to the concept of particulate nature, that is the constituent particles of any matter, a small tidbit has been given here about our rich heritage, where it can be seen that many Indian philosophers talked about the smallest particle of any matter, the smallest part of a matter, and it was in the Indian philosophy, in the Indian science, the early historical science, has been mentioned that सबसे छोटा part of any matter, that idea about the smallest part of any matter which cannot be further divided, is Parmanu. So it was named Parmanu, which means atom. So the Indian sciences have been quite ahead of the times, historically as well. Indian philosophers as well as Indian sciences have been quite ahead of the times, because in the ancient texts we have seen the mention of atom well before it was actually discovered by the modern science. So the concept of atom was pretty well introduced in the Indian sciences, where the atom was called as Parmanu. That is, the philosopher Acharya Kanad, he believed that the matter is made up of tiny, indivisible, eternal particles called Parmanu, which means they are indivisible, they cannot be further divided, and every matter is made up of these atoms, which he called Parmanu. Right, now moving ahead to the actual content of this chapter, which talks about the different states of matter. The first state, beginning with, is a solid state. Now, we all know what exactly are solids. We are surrounded by many substances which are solids. So any substance which has a definite shape and a definite volume is a solid. So what I mean by definite shape and volume is, if I have an iron nail, this iron nail, be it at my home or at your friend's home or in the school or anywhere in the universe, it will occupy the same, it will have the same shape. The shape will not change, of course, until and unless an external agency or pressure has been applied on it. So at the same pressure, we will find that iron nail ki shape remains the same. Secondly, if I take this example of wooden block, the space that it will occupy at your home, at your friend's home, in school, or anywhere around you would be the same. That means the volume of this wooden block remains the same everywhere around you, of course, because it is a solid. So solids, the first property of solids is that they all have a definite shape and definite volume. Now, why exactly is it so? This is because solids have a strong intermolecular force of attraction, as we discussed here, which results in ensuring that the particles are very close to each other and they don't move apart. Now, when the particles remain very close to each other, this means that the shape is fixed and so is the volume. You can see, since all the particles have been pushed or squished into the small space, they have no space to further move. and therefore the space they occupy remains the same, and the volume they occupy also remains the same. At the same temperature and pressure, please keep that in mind. The temperature and pressure need to be constant for this property to be valid in every condition, right? So if you ask me, if I take an iron nail and I start heating it, yes, it will expand, because that's a property. Metals expand on heating, substances expand on heating. So therefore, this is why it is, I've mentioned it very specifically, that at a specific temperature and pressure, the things, when they occupy the same space and volume, that characteristic is primarily attributed to solids. Now, apart from that, another factor, another thing mentioned here is that what exactly happens to these particles when they are inside any state of matter. What exactly happens to these particles? So when I say that force of attraction is pretty high in solids, as it is mentioned here, that the intermolecular force of attraction is pretty strong. Now, these force of attraction actually hold the particles together. But are these particles actually at rest? Are they stagnant? Are they not moving? Or are they moving? Let's go back to this simulation here and try to understand. So I have taken here, in this case, the neon in its solid form, the atom of neon, multiple atoms of neon in solid form. Now if I look closely here, if I keep on reducing the temperature, we know that the energy reduces, right? So I have reduced the temperature. I'll just convert the temperature reading into degrees Celsius. So it is about the temperature of minus 272 degrees Celsius, as you can see here. Now, the particles are almost at rest, right? Now, if I start to increase the temperature and bring it to about somewhat near the room temperature, you can see that the particles have started to vibrate. It is nowhere near the room temperature though, but the particles have started to vibrate. Now, please keep this in mind, that particles of solid, liquid or gas keep on vibrating to and fro. That means they show some oscillatory motion. They keep on vibrating about their own position, right? I'll just increase the temperature a bit. As you can see here, in this case I've taken water molecule and it is in the state solid. So in case of solid, you can see that the particles are very close to each other and it is forming again the solidified form of water, which is ice. So when I reduce the temperature, I can see that the particles are coming very close to each other, and now it is to be understood that every single particle here in every single state of matter is always in motion. That means they're always vibrating, right? The particles can only move to and fro about their positions, that is, they vibrate or oscillate, but cannot move past each other. This is what happens in solids.